Hi everyone, welcome back to PRAKASAM tutorials. In this video, I am going to discuss about movements of the random variable example. The example is statistically independent random variables capital X and capital Y have movements. M10 is equal to 2, M20 is equal to 14, M02 is equal to 12, M11 is equal to minus 6. Find the movements M22. Coming to the solution, given that the random variables x and y are statistically independent random variables, given that the expectation of x is, x and y are the independent random variable and its independent random variable condition is the joint density function is equal to product of their individual density function and expectation of product of random variables is equal to product of their individual expectation. These two are the conditions of the statistically independent random variable conditions. So given that M10 is the first moment of the random variable and it is also represented as M10 is also represented as expectation of x and it is also represented as x bar which is equal to 2 from the given data. M20 is the second moment of the random variable and it is also represented as expectation of x square or x square bar which is equal to 14. And M02 is the second moment of the random variable y, that is expectation of y square or y square bar. So from the given that and its value is 12 and another second order moment from the given that M11 is the expectation of xy which is minus 6. So calculate second moment M22. So now we are given that expectation of x there, expectation of x square is there, expectation of y square is there. So from the given data, expectation of y is not there, not required. Given that expectation of y not there. So first calculate expectation of y value. So using this condition, using this expectation of xy is equal to expectation of x into expectation of y expression, first calculate expected y value. So given that expectation of xy value is minus 6, expectation of x value is 2, minus 6 is equal to 2 into expectation of y. So therefore, expectation of y is equal to minus 3. So now we can calculate M22 value. So we know that M22 is equal to expectation of x minus mx whole square y minus my whole square. Mx is the mean value of the x and it is also represented as x bar. My is the mean value of the y and it is also represented as y bar. So this equation is also written as expectation of x minus x bar whole square into y minus y bar whole square. So given that x and y are the independent random variable, so expectation of this within the bracket term is equal to product of their individual expectation. That is expectation of x minus x bar whole square into expectation of y minus y bar whole square. So now we are applying the a minus b whole square, x square plus x bar square minus 2x x bar. Here also applying the a minus b whole square, expectation of y square plus y bar square minus 2y y bar. And after that applying the expectation property, that is expectation of sum of random variables is equal to sum of their individual expectation, that is RHS term expectation of x square plus expectation of x bar square minus 2 expectation of x into expectation of x bar. And the second term also applying the expectation property, expectation of y square plus expectation of y bar square minus 2 expectation of y bar. So expectation of x bar is x bar, expectation of x is x bar. Here also expectation of y is y bar, expectation of y bar is y bar. So x bar square minus 2 x bar square minus x bar square, y bar into y bar square minus 2 y bar square minus y bar square. So therefore, M22 is equal expectation of x square minus x bar square into expectation of y square into minus y bar square. From the given data, expectation of x square value is there and expectation of x value is there and substitute that values into here. The M22 value is 30. So given that e of x square value is 14, e of x value is 2, 14 minus 2 square into, given that e of y square value is 12, e of y value is minus 3 whole square. And simplifying, reducing RHS term, finally we get the M22 value is 30.